Shani, and I will explain about the bearing parts and the conclusion for this project. Before we start, I will introduce my team members. The first one is Aisha binti Alias. She will explain about the springs and the discussion. And the next one is Melissa. She will explain about the screw and fastener and the introduction for our projects. And the last one is Aman Christina, and she will explain about the shaft parts and the expected outcome for our projects.
The title of the mini project is a modification of a seesaw for safety purpose. As we know, a seesaw has multiple mechanical parts that can be harmful to the children who are using it, and thus proving the title for our mini project to remodify the mechanical parts of a seesaw. The introduction: mechanically, a seesaw is a lever that consists of a beam and a fulcrum with effort and load on either side. The seesaw lacks safety properties like having sharp edges, less support, and less stability, mainly from their mechanical parts. Thus, the seesaw is designed for the safety of children who are using it. The components for modification that is done in this mini project is the spring, screws and fasteners, which is the mat, a shaft, and the bearing in a seesaw. The design objectives for our mini project is first, to improve the safety aspects of at least 3 of our components in a seesaw. Second is to increase the maximum load, spring index, and the stability of the spring. Third is to make sure the nuts have less bearing stress with a washer compared to without a washer. And lastly, to avoid failure and any potential consequences that certain material may be present in bearing. However, our main objective will be to improve the safety aspects of at least 3 or 4 components in a seesaw.
Hi, Assalamualaikum. My name is Aisha binti Alias. My metric number is 201110736, and I will talk about spring component in our seesaw. First, what is spring? Spring is a mechanical device that can define as an elastic or resilient member whose main function is to deflect under the action of load and recover its original shape when the load is removed. It is also used to store energy. From this formula, the spring that we got, the spring rate that we calculated is 5,662.137 Newton per meter. From the spring rate, we can find the mean diameter, which is 11.37 centimeter. Then we find the value for stresses, which is from this formula, we get 129.73 megapascal. And then we find the spring index by using this formula, and the C is 11.37. There's no for the curvature effect, the stress concentrated type of effects on the inner fiber due to curvature, so it can be ignored for static ductile condition due to localized code working. For the maximum shear stress for helical stress, we use this formula. From this formula, we get a value of 138.9 megapascal. And for stability and absolute stability, we use this formula. From this formula, we can see that there is no buckling because the critical yield is higher than the yield strength. So for torsional yield strength, we can get the value, which is this, 2 values. We use this formula to find it. Moving on. The maximum loading can go up to 170 kg each side, while the spring constant is now 5,662 Newton per meter instead of 3,000 Newton per meter. The value is still below the critical deflection, thus ensuring the spring will not buckle under the maximum operating load. Our objective to increase the maximum load is achieved. We want to improve the spring index to increase its stability. So the spring index is still within the preferred range, which is less than 12 but more than 4. The mean diameter of the spring is decreased to 11.73 centimeter, and the spring wire diameter is increased to 1 centimeter. By increasing the wire diameter, the spring will be stronger because the oil tightens, thus reducing the spring index. The bigger the mean diameter, the weaker it is. So we decrease the previous seesaw spring to make it stronger than before. From this table, we can see that before and after of the spring properties. For the minimum spring, before we use 15 centimeter. After we use 11.37 centimeter. Before modification, we use for wire diameter we use 0.7 centimeter. After modification, we use 1 centimeter. So from the diameter, we calculated the spring index. Before it is 21.43, so it is over the range. Well, after modify, it is in the range, which is 11.37. For the spring rate, we calculate the before is 592.84 Newton per meter, and after modification it became 5,662.1 Newton per meter. For the material of the spring wire, we use chrome vanadium. For the spring end, we use material steel alloy, and the type is plain end with both ended pivoted to the ground or something. For the length, we use 50 centimeter.
For the components for modification, I'll be presenting on the screws and fasteners. I'm Melissa Lawrence, and I'll be presenting on the nut part of the screws and fasteners topic for this project. A nut is a hardware device that mechanically joins or fixes two or more objects together. In general, fasteners are used to create non-permanent joints, that is, joints that can be removed or dismantled without damaging the joint's component, which in this part is the nut that is used to fasten the shaft that holds the frame for the seesaw. This would be the CAD drawing of nut. The 2D design was made first of the nut, and then it was extruded. The sides were chamfered for 45-degree angle, and then the threads was added. This is a CAD drawing of the washer for the modifications, and this is a CAD drawing of the nut and the washer. A stress analysis was done to see the difference between the bearing stress between the nut and the steel frame and the bearing stress between the washer and the steel frame. And we can see that the bearing stress for the washer and the steel frame is lesser compared to the nut and the steel frame, thus proving that adding a washer is better in this case. A property analysis of nut was also done to compare the difference between the number of 303 and material and the number of 304 material. Even if the modulus of elasticity is the same for both the materials, the yield strength for the material of 304 is higher compared to the material of 303, thus helping in the safety factor of the seesaw modifications. Thank you.
Assalamualaikum and hi, my name is Nur Amal Christina binti Cik Shafi'i. My matric number is 201110807. Now we want to talk about shaft. We go first to the introduction. In general, shaft have 4 types, which is transmission shaft, mesh shaft, axle, and spindle. For the seesaw, the axle is quite usable because axle is the type of the shaft that rotating element like wheel, which fits in housing with bearing. The axle is the non-rotating element. At the upper right is our design. We use the CATIA. From top to top, we make a thread, and bottom from the CATIA or design is the drafting have 3 view, which is view bottom view, top view, and side view. Now we go to the another slide is shaft analysis. Shaft analysis, first we go to the at upper right is our calculation. We use shear and moment diagram to calculate maximum bending stress. For the modification, we change the shaft diameter from height to lower, which is from 40 mm to 30 mm to accommodate a higher maximum load. The range of this property is 19 until 32 mm. So the 30 mm is within range. The calculate maximum bending stress as a result of the maximum operating load is 37.89 megapascal, which is not a major issue for the material that we select. The material is AISI 1018 steel hook roll. At the bottom, we make a comparison before and after for the diameter. Before, diameter is 40 mm and after is 30 mm. For the before, the maximum bending stress is 15.89 megapascal, and for the after is 37.899 megapascal. Now from this maximum bending stress, we get the maximum load is diameter 30 mm.
I will explain about the bearings. What is a bearing? Bearing was used to guide and support an oscillating, rotating, pivot, sliding shaft or any wheel. There were 3 main functionalities of a bearing. Firstly, bearing was used to decrease friction while keeping the shaft moving smoothly and consistently. This is one of the most prominent functions of the bearings. Next, bearing was used for supporting a load which can effectively decrease the energy and effort needed to move or slide an object. Lastly, the bearing was used for guiding moving parts such as pivot, shaft, and wheel, which the shaft readily pushes the bearing in the same direction in which it is moving load. Before we go further, I will explain a bit how I design a bearing in the CATIA V5. First one, I use bearing rings, which is the outer rings, and then I draw inner rings and the ball. The next one, and lastly, I will assembly the part, and this is the result as you can see in the picture. And this is a symmetric view of a bearings. So material for bearing was analyzed to avoid failure and any potential consequences that certain material may present. So as you can see in the picture, this is one of the example of the failure, which is the rolling contact fatigue or RCF. So there was 3 factors to be considered in material analysis. The first one is bearing must be able to handle the anticipated pressure and weight of the radial loads, axial loads, and combined load in order to function efficiently. And the next one is bearing must have a speed dedicated to withstand the extra force added to the bearing motion. And the last one is the maintenance. Okay, by balancing the cost of the bearings with the life performance, it can be critical in avoiding expensive downtime. So as you can see in picture, this is a material analysis before and after modification. So the type of bearing that were used in seesaw were the stainless steel bearings. Stainless steel bearing were divided into 4 materials, which are 440, 304, 316, and 420. And the most common stainless steel was 304 and 4200. 304 stainless steel bearing have a good corrosion resistance, heat resistant, and low temperature strength. This type has small friction coefficient, high unit speed, simple structure, low manufacturing cost, and requires little maintenance. Hence, after analyzing all the considerations, we decided to modify the material from 420 to 304.
Expected outcome. Expected outcome, we explain about improvement and modification for four components, which is spring, screw and fastener, shaft and bearing. We go one by one. Spring. To increase the maximum load, the diameter of the wire must increase to strengthen the spring and can reduce the index number. Screw and fastener. For the safety factor in the seesaw, a washer must added before the nut to reduce the load caused by the shaft. Shaft. To increase the maximum load, the diameter must change from a large value to small value, according to the range provided to get a good maximum load. Bearing. Modified a material of the bearing from 420 to 304 of stainless steel is to get the good performance of the...
For discussion, first, the spring. We want to improve the spring index to increase its stability. By increasing the wire diameter, the spring will be stronger because the cold hardens, thus reducing the spring index. And a bigger mean diameter will make it weaker, so we modify it by decreasing the previous seesaw spring to make it stronger than before. Next, the washer is an untreated piece that fits onto the bolt shaft. A nut pulls the workpiece together along the bolt shaft, therefore adding a washer before the nut will have distributed the load caused by the shaft. Other than that, we can also change the hexagonal nut to nut with a cap for safety purpose. Based on the comparison of screw and fastener for the properties in the table of two types in the material, the 304 stainless steel have higher specification compared to 303 stainless steel. However, the ultimate strength of 304 stainless steel is lower than 303 stainless steel. So the 304 stainless steel will be more brittle, while 303 stainless steel will be more ductile. On the result, we can know by brittle material, the ultimate tensile strength is close to the yield point, whereas in ductile materials, the ultimate tensile strength can be higher. For the shaft, we modify the shaft diameter from high to low to accommodate the higher maximum load. The range of this property is within the range that we wanted. The calculated maximum bending stress of the maximum operating load is 27.89 MPa, which is not a major issue for the material that we select. Next, the type of bearing that were used in seesaw are the stainless steel bearing. Most common stainless steel used was 304 and 420 materials. The 304 stainless steel bearing have a good corrosion resistant, heat resistant, and low temperature strength. This type has small friction coefficient, high unit speed, and simple structure, low manufacturing cost, and require little maintenance. Hence, after analyzing all the considerations, we decided to modify the materials from 420 to 304.
So the conclusion for this project, we designed and did the drawing part for the seesaw. The objective of the project had been successfully achieved, and improvement has been done for every component part that we had chosen, which are springs, nut, shaft, and bearings. With proper and suitable analysis by using calculation, the design for seesaw has been improved. To make an improvement for the springs, the wire diameter for the spring has been increased. The coil was tightened, thus reducing the spring index, and the spring has become stronger. We'll also redesign the screw and fastener by adding the washer and the nuts to make sure the nuts have less bearing stress. The improvement for the shaft also has been done by modifying the diameter of the shaft due to an increased maximum loads. Hence, to avoid failure in any potential consequences that certain material may be present in the bearing, a material analysis for bearing has been done. The material has been modified from 420 stainless steel to 304 stainless steel.
Audio Jungle.